are going to learn about our topic number 14, that is how to declare a variable in C and its mechanism. So let's move on. Variable and its mechanism. So as we have talked about the variables, that the variables are the name location in the main memory used to store data that can be manipulated during runtime. So we have talked about and learned about the variables, that how to name the variable in the previous video. We have learned about the naming convention. Now we are going to learn about the variables and its mechanism. So variables are the named locations, okay, in the main memory. Now what is the main memory? That will be the RAM. Okay. Now used to store the data. Why we create variables? The question arises. Then the answer is so simple. That is, it is used to store the data. Therefore we have created this. That can be manipulated during runtime. Now we have talked about the naming convention of the variable, and in that we have seen different rules. Okay. Now we will talking about the variables. So it is the named location, okay, in the main memory used to store data that can be manipulated during runtime. Now moving on the next thing, that is syntax to declare a variable in C language. So this is very important topic, how to declare a variable in C language. So it's so simple and easy to understand. So let's look at this. Here you are seeing an optional part, and here you are seeing an required part. Okay, so these all are optional part, and these all are the required part, that is you need to provide this. Otherwise your variable is not going to creating in C language. And this is an optional part which is telling us that you can use it or you may not. Okay, so what are the optional part and what are the required part? Let's look at this. So we will learn about the qualifier, also storage specifier and modifiers. And qualifier is divided into three sections: volatile, constant and restrict. Okay. Storage specifier. Specifier has been classified into four categories, that is auto, static, extern and register. Okay. Now modifiers. Modifiers also has been classified into four categories, that is signed, unsigned, long, long means double. Okay. Now this is an optional part. Qualifier, storage specifier and modifiers are the optional part. So let's look at the required part, that what is our requirement and what is the required part that we need to declare, and by the declaration of this syntax we can create a variable in C language. So let's look at. Here you are seeing the data type, then variable name with semicolon. Now what this means? The type of data that variable is going to hold, it means. So different data type we have studied. So data type, integer, char, float, double, void, these all are the data type. We have studied about the size of these all, okay, in the previous video in the series of the Udemy package of C language. So what we have studied here is that data type. Okay, now data type can be integer, can be character, can be float value, can be double value, or can be void also. And void means empty, that its size is to be 1, considered to be 1 byte. Okay, now this is the variables. Now what do you mean by variables? As we have studied about, the variables are the name location in the main memory used to store data that can be manipulated during runtime. Now this is the variable, that the name of the variable you have to declare here. So this is the required part, that you need to specify any type of data with its variable. If you specify this, then you are creating a variable in C language, and this is an optional part. So you can use this all also. What not required part? It is the required part. Data type variable. This is the required part, and this is how we can declare a variable in C language. So let's move on the point that to be noted down, and that is so important point. So our first point is qualifier, storage specifier, and modifiers are the optional and can be used with if needed. So we have studied that the qualifier, storage specifier, modifiers are an optional part. So this can be used if needed. Now the next point is that sign is the default modifier. That means if we not mention any modifier explicitly, then sign is taken into consideration implicitly. So what it considered here is that if we not apply any modifiers like sign, unsigned, long or double, so what it does that the default value of the modifier is signed. Okay, the default value of modifier is signed. It is the system default value. Okay. Now, if we provide unsigned, the value will be in the range of unsigned, the value will be in the range of long, and the value will be in the range of double. Okay. Now, this is the most important point also. Auto is the default storage specifier. That means if we not mention any storage specifier explicitly, then auto is taken into consideration implicitly. Now, here the thing also goes out that auto is the default storage specifier. Now, storage specifier we are talking. So auto is also a storage specifier, default storage specifier of the system. So if we not mention any storage specifier, then it is going to be automatically implemented into the system auto. Now, the most important point we have seen that is the modifier long and the qualifier restricts for pointer are supported in only C99 version of C language. So this is very important that the modifier long and the qualifier restrict for pointers are supported in only C99 version of C language. So here you are seeing that long and restrict. Here you are seeing modifier long and restrict qualifier. So these two are only supported in C99 version of C language. So this is the most important point. Two variables must be separated by semicolon. We have studied because comma is behaving like an operator as well as separator. So the variable which we are going to declare must be separated with a comma. Now variables declaration must be terminated by semicolon. We were aware with this things that whatever we are just going to write in the C language, we have to terminate it with semicolon except the looping statement. Okay. Now variables declared must be terminated by a semicolon. So this is the most important point that you need to consider in your topics, in your mind, that qualifier, storage specifier and modifier are optional and can be used if needed. This was the first point. Second, that the sign is the default modifier. That means if we not mention any modifier explicitly, then sign is taken into consideration implicitly. And the third point and most important point was that outer is also the default storage specifier. That means if we not mention any storage specifier explicitly, then auto is taken into consideration implicitly. And the fourth point that we have studied that the modifier long and the qualifier restricts for pointer are supported in only C99 version of C language. The fourth and the fifth point was that the two variables must be separated by a comma. So this was also very important point. And the last I think that it was the sixth point that variables declaration must be terminated by semicolon, and that is so important point also. So these all are the point to be noted down. So you might we remember these all the facts about this optional part of the variables, that is the qualifier, storage specifier and modifiers. So let's move on the next thing, that is variable naming convention used in C language. So we have talked about the naming convention of C language. So let's look at the rules again also for the better understanding of variable and its naming convention. So a variable name in C language must start with an alphabetic letter like capital A to Z to small a to Z. So this is an alphabet character or letter and can be followed by any sequence of character except an embedded space, hyphen and dot. So what we have studied here is that a variable name in C language must start with an alphabetical letter. Okay, so alphabetical letter can be capital A to Z or small a to Z and can be followed by any sequence of character. So we have studied here is that it must be started with an alphabet and followed by any sequence of character except space, hyphen and dot. So let's look at the example of it. Here you are saying to num. Now this is not an alphabet character. What the variable name, we have studied that the variable name must be start with an alphabet. So here it is not starting with the alphabet, therefore its variable name is incorrect. That is false. That is not the way of writing a variable name. Now here you are saying num. This is alphabet letter, and you are seeing here a hyphen. Therefore it is also not going to be make a variable. So this is also a wrong variable. Naming convention of this variable is wrong. Okay, now here you are saying a space, so this is also wrong. Here you are saying dot, that is, so this is also wrong. Here you are seeing that it is starting with the alphabet character and followed by any characters, therefore it is right, and there is no space and hyphen and dot also. Now this is true. Why it is? Because we have not used hyphen, we have used an underscore, and an underscore can be allowed because this rule is saying that underscore can be allowed, because we have to embed spaces, hyphen and dots. So what the rule is saying is that a variable name in C language must start with an alphabetical letter A to Z, okay, and can be followed by any sequence of character except an embedded space, hyphen and dots. So what here we are using underscore, so this exists, therefore it is true. Now these all are the example you can solve similar way. Let's look at this. Here hyphen, therefore it is wrong. Here dot, therefore it is wrong. Here space, you are not allowed to give a space in variable name. So this is also a wrong way of declaring a variable, wrong way of naming a variable. Okay, now net underscore salary, that is the right way, true, because we are using underscore and it is followed by any sequence of character and starts with an alphabetical letter, therefore it is true and it is right way of writing. This is also a right way of writing, this is also a right way of writing. So here in these three things you are seeing because C is a case sensitive language, so we can say that C is a case sensitive language, so therefore this all variables are different variables. Net underscore salary is different variable, capital and here et underscore salary is a different variable, and capital net underscore s capital al ary small, it is also a different variable. Okay, what it is a variable, what this is not a variable, because we have considered a space here, we have considered a dot here, and we have considered a hyphen here, therefore this is the wrong way of naming a variable. Now moving on the next thing, that is the second point, a variable name in C must not be a reserved keyword supplied by C language. So what we have listened here, what we have studied here is that the variable name must not be a reserved keyword of C language. So integer is a reserved keyword of C language, if is a reserved keyword of C language, code is a reserved keyword of C language, static is a reserved keyword of C language, extern is a reserved keyword of C language, auto is a reserved keyword of C language. This is not a reserved keyword, because why it is not a reserved keyword? Because it is starting with capital I, and small I and T is the reserved keyword of C language. This is a capital int, so this is true for writing a variable name. This is also a true for writing a variable name. This is also a true for writing a variable name. This is also a true, and this also a true. Why it is so? Because C is a case sensitive language, and we need not to use this. Because all the reserved keyword is written in small letter. But here when we changes the case of these all the reserved keyword, then this can be exist as a variable name, but this cannot be exist as a variable name because this is a reserved keyword. So you have to remember a variable name in C must not be a reserved keyword supplied by C language. So let's look at the second one. And the third rule we can say, a variable name in C is case sensitive, as we have studied. That means uppercase letter and lowercase letter are different from each other. So we have talked about these things external. So this is not going to be a variable. Why? Because it is a reserved keyword. Because it is starting with small, and we have studied here is that all the reserved keyword is going to start with a small letter. So this is a reserved keyword. This is not violating the rule second. Okay. Therefore, it is not a variable. It is a variable. It is also 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 a variable. So we have studied here is that a variable name in C is case sensitive, and these all are the different variables except this one because this is a reserved keyword. Okay. Now, moving on the some of the most important example that num2. So we have a question for you that which one is variable and which one is not variable. So let's look at this is a variable. Yes, it is. Why it is? Because it is starting with alphabet letter and followed by any sequence of character, and there is no any space, hyphen and dots. Therefore, it is variable. It is also a variable. It is also a variable. It is also a variable. Okay. It is also a variable. It is also a variable. What all these are different variables. All these are different variables. Why it is so? Because variables name are case sensitive in C language. Okay. We have studied about the rule third that variable name are case sensitive in C language. Okay. Next, moving on the data type supported in C language. That so let's look at the data type that is supported in C language. The C compiler provides 5 fundamental data types, which ensures what it ensures the size of to be allocated in the memory and the types of valid data for that memory location. So this is very important point. 5 fundamental data types. So C compiler provides 5 fundamental data types. So what it ensures us that the size to be allocated in the memory, what kind of size is going to be allocated in the memory, and the types of the valid data that for the memory location. Okay, now let's look at the data type supported by C99 version are given in the table. So let's look at data type. So data type can be different. Okay, so these all are the data types which we are going to use in C language. So let's look at the wide data type. So wide data type size is 0 byte. Okay, wide data type is size is 0 byte. That is no value in the here. It is empty. We can say wide is an empty data type. Now we will talk about the char. Char is the character. It can only store a character. Okay, character constant only. So its size is 1 byte. Its size is 1 byte, and it can only contain or store a character. Okay. Now int is the integer data type. Its size is 2 byte and it can store a round integer number. Now float is also a data type whose size is 4 and it can store a fractional number. Okay. Now double is also a data type and its size is larger than the float, that is 8 byte, and it can store a long fractional number. So these all are the data types supported in C language. So let's look at the point that we noted down. So the data types void is used to declare a function explicitly returning no value. So we have talked about the void data. It is not going to return any value. Okay. It can also be used to declare a generic pointer. So we can use it to declare a generic pointer. Okay, now the most important point that the C and the second point is that the version C99 also support the type underscore bool, underscore complex, and underscore imaginary. So bool means a boolean value, it can be true or false. Underscore complex, so it is a complex value that is going to be stored, and underscore imaginary means it is a imaginary value that can be stored. So you have to remember this point that the version C99 also supports the type underscore bool, type underscore complex, and type underscore imaginary. So let's look at the example of the variable declaration in C language. To reserve a memory location of 1 byte named C1, that we have studied, to reserve a memory location of 1 byte named C1, just as for example we are seeing here that the character data type is storing a variable named C1. So this is the way of declaring a variable. C1 is our variable name. So this variable name is following the rule of our variable convention. So what was the rule that we have studied, that the letter should be start with the alphabet character. So it is starting with alphabet character followed by any character. So and there is no space, hyphen, and dots also, therefore it is following the rule of variable. So therefore it is a variable. Now we have declared a variable C1 whose data type is char. So actually what happened in the main memory is that it the what happened in the main memory is that the variable name C1 is going to be allocated in the memory whose size will be 1, and its address will be according to the system. Here it is F4, so it is a hexadecimal value. Okay, now this is what do you mean by that is the type of data. So it can only be one character. To reserve two memory location each of 1 byte named C1 and C2 respectively. So let's look at that how we do this. So we are using a char data type to do this because we have to allocate 1 byte of memory in the RAM. So how we will proceed is, let's look it. Here it is the char data type now C1 and C2. C1 and C2 is the two variable which is allocating in the memory, and it is separated by the comma as a separator. So comma is working as a separator here. Now this is the char which is the data type. Now this is used to accept one char, means it can accept a character value only. Now, to reserve two memory location, each of 1 byte having value A and B respectively, named C1 and C2, then this can be done by this way, that we have to use a char data type. Now C1 equal to single quotes A, this because it is a string, and single quotes B because it is a constant, because character allowed only character constant, because it is a character constant, because this we have studied about the character constant, because in the previous video we have talked about the character constant that should be within the single quotes, that should be within the single quotes, therefore we have declared here. Now to reserve two memory location each of 2 byte having decimal value 20 and 30, we need to provide integer there, integer data type. Then how we will perform this? We have to use integer data type num1 equal to 20 comma num2 equal to 30. So this is the way of declaring the integer value, the character value. So let's look at that, to reserve two memory location each of 2 byte having octal value in it. So octal value is starting from 0. So it should be 0 anything, 0 1 2 and 0 2 2, named number and m2. Then we have to use integer, because integer that is the value, integer num equal to 0 1 2 comma num2 equal to 0 2 2. Now to reserve two memory location of each of 2 byte having hexadecimal value, so hexadecimal value starts from 0x and any number of value or a character 0x e5 and 0x e6 name the number and m2 respectively. So we need to provide here integer. Okay, integer is that value that is going to get this value. Now we have declared an integer here. Now num1 equal to hexadecimal value and num2 equal to hexadecimal value, that we need to provide here, and with terminated with semicolon. Now okay, 0 reserve 3 memory location of the size 1 byte, 2 byte, 4 byte and 8 byte having value a equal to 65, okay, comma 65.00 and 65.0000 named as E1, N1, F1 and D1 respectively. So this is the way of recognizing the facts about having a value way, that what is it is going to contain in it. Now let's look at the CAD. So we have studied about the character data type, integer data type, double data type and float data type. So let's look at its the significance of doing it. Because character data type is going to store only character constant only, and integer data type that is going to store only integer value, double data type that is only going to store the double value whose size is 8 byte, and float data type that is going to store only float value. So this is how we need to convey these all the things. Now I have a question for you, that write an application program in C language named P1.C to reserve a 2 byte memory location in the main memory named num. Now how you will perform this, and also display the relevant information as given. How and what types of information that needed to be in that? The default value of the location num, the address of the location num and the size of the location num. So you need to provide these all the things. Then how you will proceed? So first listen the question, first write down the question, first think about the question, that what is the question. So here the question is that write an application program. So we have to create an application program in C language, and we have a name it as P1.C or anything like you want to consider, to reserve a 2 byte memory. 2 byte memory means how we can do this? By using the integer data type. Memory location in the main memory named num. Now also display the relevant information. What type of information? The default value of the location num, the address of the location num and the size of the location num. Then how we will perform this? Let's look at it. So we have a set of program that is needed to declare. So we have declared a header file. That is so important in C language. Hashtag include history.h is the header file, and it consists lots of the functions that we have considered, that is printf function. Now hashtag include connu.h, this is the control input output header file, and this is the standard input output header file. Now we have mentioned about the main function, that it is a function and its type, returning type here is a void. So it means empty, it is not going to return any value. Now this is the curly braces. The curly braces is used to open the main function. Now after this we have declared variable num, so it is going to be allocated in the memory of integer type and its size will be 2 byte. Now we have used the clr function whose work is to clear the screen. Now what it does is that it clears all the screen, whatever is written on the screen. Now when we proceed into the printf function, its work is to print whatever is written in the double quote, is to print whatever is written in the double quote in the screen of the C language. That is the standard output header file. Now moving on, this it should be within the double quote. So now we have provided a value in num equal to percentage. Percentage is the format specified that is going to be replaced with the variable's value. Backslash n is the escape sequence, therefore a new line will become, again a new line come. So I am using a 2 new lines there. Then so what will be happen? Value in num is equal to percentage, whatever the value in num, that will be transferred here. Okay, now I have used the printf function again, which help us to display message on the screen, as we have seen here that value in a num, so same as address of a num. So for finding the address we use format specifier %p, and that is going to get you the address of that value, that the variable num. Okay, now we have used the escape sequence for the new line and then again for the new line. Now and is the address of the num, and is holding the address of the num, and we have used the format specifier which help us to find the address of that variable. that is the percentage t. Now after that we have terminated this, and we have moved forward for the printf function again, and we have printed the size of the num in the void. That should be percentage, that can be integer value. So we have used the size of operator, which help us to find the size of the num, which is of type integer, and we have studied that the integer type is 2 byte. Therefore, here the percentage d will be 2. So now size of the num in byte will be 2 here, and it will be the address of the num, variable num. So address of variable num can be, the address is generated by the system. Therefore, it will provided by the system, and the value which we will pass in the num, that will be replaced with this. And finally we have written that while, in that while we have written not kbhit function. So after when user print any kind of function, then it will execute. Finally we have terminated this. So this is our program of p1.c. So we have the thing, and we have studied about this thing. Let's look and go forward for the another question. That is, write an application program in C language named the p2.c to reserve two memory location, each of 2 byte in the main memory, named the num1 and num2, having the value 20 and 30. So what is the question? First think about the question, write down the question, and you need to memorize that question with your mind, that how we can solve this question. Now we are considering application program in C language named, and whatever you will give the name, that is your desire, that I am using p2.c to reserve two memory, to reserve two memory location, each of 2 byte. Now we have studied about the integer data type store 2 byte of memory location. Therefore we will use integer data types, and we, that data type variable name must be num1 and num2, because it is giving us, even here is that the variable name should be num1 and num2, and num1 contain 20 value and num2 contain 30 value. Here it is given num1 contain 20 values and num2 contain 30 value. So we need to declare here. Also display the relevant information as what we have done so far. The value is stored in the variable, whatever the value is stored in the variable, that we need to display, and the address of the variable, whatever the address of the variable is generated by the system, that we need to consider here, and the size of the variable, that the size of variable, that we will use size of operator. So let's look at the solution of it. So here you are seeing that we are using the hashtag included studio.h, which is our header file, and hashtag included conio.h, which is also our header file. So let's look at and simply work on that. What we have just done here is that write an application program in C language p2.c to reserve two memory locations. So we are using two memory location. So memory location is a variable name, that is the num1 and num2, whose value is going to be 20 and 30. And here we are just considering for the 2 bytes, so therefore we will use the integer data type, and also we are displaying the values stored in the variable name and the addresses of the variable and the size of the variable. So therefore we will use size of operator for this, and we will use percentage p format specified for this, and we will use percentage d format specified for the value stored in the variable. So let's look at that how we will do this. So we have used the main function here, whose return type is void, which means empty, that it will not return any value. Then after that we have opened the curly braces here. Now after that we have uses our two variable num1 and num2, which is storing value 20 and num2 is storing the value of 30 here, and whose data type is integer data type. Therefore its size will be 2 byte. Now after that we have terminated this, that is from semicolon. Then what happened is that we are using the clr function, whose work is to clear the screen. Okay, whose work is to clear the screen. So it will clear all whatever is written on the screen. Okay, now after that we are considering the printf function for displaying the value of the stored in the value, for displaying that value that is stored in the variable. So we are using the printf function. Now in that printf function we are using percentage d, which is a format specified, \t, so it will create a tab between these two values, that is percentage d and percentage d, format specifier replaces the value with the num1, and here format specifier replaces the value with the num2. So whatever the value num1 contain, that will be replaced here, and whatever the value contain in num2, that will be replaced here. And this is the escape sequence. So tab, it is its work is for tabbing the two number. Now after that we have used the escape sequence, that is new line, that it create a new line, again a new line. So what happened here is that num1 is going to replace the value with this format specifier, and num2 is going to replace the value with this format specifier. After that, what will print here is that 20, and what will here print is that 30. So therefore 20, then tab, then 30 will be printed. After that a new line will come. So this is used to print these things, that the value of the variable. Now after that we have to print the address of the variable. Now how we will proceed it, let's look it. So printf function we are using because it is an inbuilt function in C language and comes under the studio.h header file. And we have studied that whatever we wanted to print on the screen, that should be within the double quotes. So we are using a percentage p, which is a format specifier, and its work is to print the address. Okay, print the address. Now after that we have uses the same function, that is escape sequence, and that its work is for tabbing the values between two values. So here number and num2 are the two variables, and we are using the ampersand operator, and its work is to hold the address of num1, and its work is to hold the address of num2. Therefore whatever the value num1 is going to contain, that its address should be here, and its address should be here, num2 address should be here in this ampersand. So because the ampersand hold the address of the variable, therefore the address of variable num1 and the address of variable num2 will be stored here. After that we have printed that address with the format, with the help of the format specifier, that is percentage p. It is used to print the address, and that is percentage d. So whatever the address will be in the system of the num1 and num2, that will be printed here. So this is the way of printing the address in C language. Now after that we have uses the again a printf function to display the size of num1 and size of num2, because size of operator help us to determine that what kind of size the value contain in it. So num1 is a variable whose data type is integer, and integer data type contain 2 byte of memory, 2 byte of memory. Okay, now so size of num1 will be 2 byte and size of num2 will be 2 byte. So overall size will be 2 byte and 2 byte. So and after that we have uses the while, not kbhit. So after when any one user press the function, press the any key like enter, then this get terminated. So this is the way of representing the value stored in the variable, the address of the variable and the size of variable. So let's look at the some of the point that to be noted down. And our first point is that only the name of the variable drops the value of the variable. That is so simple. Because the name of variables drops the value of the variable, that is going to be replaced with that. That we have used the variable name, and that is going to be 20. And we have used the num2, that is going to be 30. So whatever we have declared here is that num1 only, that will be dropped here. Num2 only, that will be dropped here. So here it will print 20 and it will print 30. So this is the way. Now next point is that ampersand and size of operator are operators. Okay, we have studied about the ampersand and size of operator. Ampersand work is to find the address, okay, and hold the address of the variable. And size of operator find the size of the variable or whatever is written within its parenthesis. So moving on the next point, that is AND is an address operator. As we have talked about, AND is an address operator which takes the variable name as the operand and drop the address of that variable. Okay, so what AND, or we can say ampersand, does is that ampersand is an address operator which takes the variable name. So it takes the variable name as an operand and and drops the address of that variables. Okay, now finally we are moving to the point that is the second point, and we can say that is the fourth point, size of operator. So size of operators takes a variable name or a data type and drops its size in bytes. So size of operator help us to determine the size. So it takes a variable name or a data type and drop its size in the byte. So this is the way and the function of the size of operator. Now finally all variables are internally addressed into the hexadecimal notation. So whatever the address contained, that will be in hexadecimal notation. So this is the important point and this point should be noted down. Okay, finally moving on the explanation that here you are seeing and, which is the ampersand, which hold the address of the variable and variable name here. So what it does is that it takes the variable name as operands and drop the address of that variable. So this is the function of ampersand. Now finally we are using the size of operator, type slash variable. So size of operator does is that it allocates and find the determines, we can say that it determines the size of in byte. Okay, now moving on some of the example that we are using the size of operator whose work is to determine the size, and we are passing a void in it. So void size is 0, and again we are using the size of operator and its work is to determine the size, and we are passing in the parenthesis that is char, and its char is 1 byte, and we are passing integer, therefore size is 2 byte. We are passing a float, therefore its size will be 4 byte, and double, therefore its size will be 8 byte. So we have studied about the data type, ampersand, and size of operator, and the variables and how it works, the combination of the variables, how to declare a variable and its mechanism. So these all are the things. Now let's look at the examples of it. Here we are seeing that we are declaring a three variable. Okay, C1, C2, and C2, and C3, which are were separated by a comma separator. Now in that we have used the char data type which holds the character. Now in that we have used the ampersand. Ampersand holds the address of the variables. So it will store the address of the variable in hexadecimal value. So address of variable in C language, that will be in hexadecimal value. So here the address of C3 is FFF4, here the address of C2 is FFF5, and here the address of C1 is FFF6. So this is how the memory is going to allocate. And again you are seeing here we are using the data type integer, and we have declared a three variable number n1, n2, and n3, which is separated by a comma separator. So what it does that, and we have used the ampersand which hold the address of the variable, means it drops the address of the variable to whatever is in the n3, that is the variable. So it hold the address of the variable. Therefore n3 address is ff4, which is given by the system, n2 is ff6, which is given by the system, and n1 is ff8, which is given by the system. Now moving on the float, again we have seen about the integer char, and you are seeing the float, it is a float data type, so therefore the value it contains, that will be float, and its size is 4 byte, and we are declaring the three variable f1, f2, and f3, which is separated by a comma operator. Now comma separator as working. Now here we are declaring the and, or we can say ampersand, which hold the address of this variable, that is f4. Again using the ampersand, this is holding the address of this variable f2, and its address is ff8, and again here you are seeing that this is holding the address of f1, and its address is ff12, that is 12. So this is what we have studied, and that is the mechanism through which it works. So we have studied about that, how a variable is declared and its mechanism. So thanks for watching. Dhanyavad.